Yeah, very good evening. Good evening. Good afternoon. Yeah. Yeah. You can hear me now easily? Okay. Am I audible now? Okay. Now audible? Fine, 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 fine. Okay. So as we are proceeding with the machine learning here, so we are doing the classification. So can you tell me which particular algo we had covered last time? Which algo I had covered last time? Yesterday I'm talking about. Okay. So that one is a ne bias, na? Ne bias, yeah. Okay, so yeah, ne bias we had covered, no? Okay. Ne bias we had covered. So we are doing a classification, and inside the classification, as I told you, there are several algorithms such as nearby classifier, we did it. And there are two particular branches of nearby is there. That is multinomial NB. And the second one is a Gaussian NB. We did it. So basically, multinomial NB is used whenever we have my Y categories more than 2, they are greater than 2. And GNB is used whenever my Y are binary values. Okay. Apart from it, we are having some another algos as well, such as K neighbors classifier. There's one more, decision tree classifier. There's one more, support vector classifier. So in this way, we are having a lot of algorithms. Okay. K-neighbors classifier, nearby classifier, distant tree classifier, all that we are having. So let's explore now one of the algorithm K-neighbors classifier. So basically now what K-neighbors classifier does actually, see, as the name suggests, it is a K-neighbors classifier. So it means K-neighbors means this algo will start looking the nearby neighbors. This algorithm will be start looking the nearby neighbors. So let's see how this algo is working. So basically when we talk about the K-neighbors, so inside the K-neighbors, there is one of the parameter, we call it a N neighbors, number of neighbors. Number of neighbors means how many neighbors are nearby to a particular data point. Okay. So this is a number of neighbor. We can just give that how many numbers we have to check. So let's see how this algo is working actually. We call it a KNN. And here we can pass on the values of number of neighbors inside the K neighbors classifier. So how many numbers of neighbors we can check it out. So number of neighbors, we can just say it as the number of K values also. Certain time we call it a K values also. Now suppose here, let me make one graph here. Suppose I'm having some data points. Let me make some data points here. This is one data point. And here I'm having another data point. Okay, some pink and green data points I'm having. So some of the data points, I can have some of the data points here also. Getting some green I created here. So we can assume that, let's consider that we are having two categories. Let's understand. We are having two different types of categories. Inside those categories, the pink category says the data points which are in pink that shows the data of diabetic, the people who are with pink data points, they do not have any diabetes. It means I'm having a kind of data set where I'm having two types of people, two types of patient data, whether they are having a diabetes or they are having no diabetes. So basically, the data points which are into the pink shade, they are the people, they are the patients who do not have any diabetes. And the shades which are coming in green, okay, green shades, these people are suffering from the diabetes. Let's say in this way. Okay, so here I can say that these people are suffering from diabetes. So these are the diabetic people, diabetic patients, and these are, let's say, no diabetic patient, who like the people who are coming into data, pink data points. Okay, no diabetic and diabetic cases I'm having into my data points. Now what I do into the KNN, now suppose I had given this data to the machine to learn. Let's assume a lot of data set I'm having, and that data I had given to the machine for learning purpose. Machine has learned all the data points. Now, when I'm putting a new data points, suppose a new patient arrived and I'm having all the input features of those patients. Now I want to know whether this patient, means whether he's a patient or not, I say, whether that person is suffering from the diabetes or no diabetes case. So I want to use a KNN algorithm, let's say. So here, when the entire training data has been given to the model, now it's a testing time. So here, let's consider, I'm giving the new point. Suppose here, let's consider this diamond. Let's consider this diamond. This is any data point. This is any input features of any person. Now we have to detect whether this person, this yellow point, whether this person is suffering from the diabetes or not. Okay, how? Now we have to use, suppose I'm using the KNN algorithm. Inside the KNN algorithm, it will be checking out all the nearby neighbors. It will be checking it out how much is the distance with the nearby neighbors. Okay. So here I will be starting putting some values here inside the value of number of neighbors. So here I'm putting values such as, if I'm choosing a value of k is equal to 1, so it means number of neighbors is equal to 1. So here I'm looking number of neighbors is equal to 1. So what will happen? that here number of neighbors is equal to 1. So here it will be checking out that what is the distance between this yellow point and nearby neighbor. So if we check it out, the nearby neighbor is this one, this pink point. So here, this one is the nearby neighbor, which is pink. So here I will say when k is equal to 1, it means start looking the first neighbor. Start looking the one neighbor. Okay. So KNN will start looking the nearby neighbor, which is 1. So here it is. So I'm giving start looking the first neighbor. So first neighbor is pink data. So here I will say one pink. One pink says that the pink data is related with a no diabetic person. So it means the new person is having no diabetes. Done. Now I need to increase this number of neighbors because 1 is not sufficient. So I will just increase this k is equal to 2. So here I'm saying k is equal to 2. It means I want to look 2 neighbors nearby. So instead of 1, I want to look 2 neighbors nearby. That what are the data points with 2 nearby neighbors? So here I'm looking. What is the nearby neighbor? This one is the nearby neighbor. So it means when I had chosen 2 nearby neighbors, two number of neighbors. So 2 pink data are there. So 2 pink says that pink data are belonging to no diabetic people. So again, it is coming to the conclusion that the new person is again no diabetic. The person does not have any diabetes. Okay. But still, I'm not satisfied. I need to increase this number of neighbors here because I need to check out entire periphery, entire radius of this diabetic, entire periphery of the number of neighbors. So here I will increase it to 3. So it means when here I'm giving the number of k is equal to 3. So here I'm looking, just check it out, all the nearby 3 neighbors. So here I'm just looking 3 neighbors. So here it is. Third neighbor is this one, green. So what does it mean? The third neighbor is this one. So 2 pink and 1 green. What does it mean? 2 pink and 1 green. So it means it is saying that 2 are in pink favor and 1 is in green. So here also we can come to the conclusion that 2 are in pink and 1 green. So it means still the person is no diabetic. Because pink shade says no diabetic. Now let's say, suppose I will increase 1 more. So what I'll do now, let me take 1 more green shade here to green shade here. Let's say here I'm taking. Let's see. That can also happen actually. So now what I'll do, I will increase my k neighbors. Number of neighbors is equal to 4. So here I will say, let me check it out, 4 numbers of neighbors. So here, instead of this 3, okay, here I'm increasing, here I'm increasing numbers of neighbors is equal to numbers of neighbors is equal to, let's say, 4. So here I will be looking here 4 neighbors nearby to this data points, which is a new data point. So here, if I say, then this is a nearby point. So it means 2 green, 2 pink. So 2 pink and 2 green. It says that it is not a proper results coming because 2 pink and 2 green. So whether the patient is diabetic or not. This is there. Okay. So here we cannot come to the conclusion because it is into the 50-50% that it can say, yeah, patient could be diabetic also. We can start putting the treatment for patient. Otherwise, Maybe he's okay or she's okay. Now here, let's increase this number of neighbors to 5. So here, let me check it out, the nearby neighbor. So this is nearby neighbor, nearest neighbor. So here, this is the pink. So again, with k is equal to 5, 3 pink and 2 green. So here it comes that again, the patient is no diabetic. So with 5 numbers now, 5 number of nearby neighbors, the majority vote is going towards that the person does not have the diabetes, because three of the nearby neighbors are coming to the conclusion that they are with no diabetes. They are with no diabetes. Okay, so that means person is quite happy because the person is not suffering with any diabetes and he can move away. Okay, no treatment is required. So this is the case. Even if I want to increase this number of neighbors to 6, let's say 6. So here, let's say 6 to 6 to 1 is, what is the nearby here? So again, nearby is this one, let's say, or let's say we can take it this one also, anyone. So 1, 2, 3, 4. In 6, 4 pink and in 2 green. So still the conclusion comes that the person does not suffer any diabetes. Okay, the person is okay. There's no treatment required here. Okay, so here now the point is that here, the point is that the KNN values, the K neighbors, the KNN, the number of neighbors, will try to check it out, number of neighbors nearby, and it will start predicting that what is the final result of the given input features, what is the Y, what is the predicted Y in various categories here. So it will be looking all the nearby neighbor. So the values which we are giving it here now, so that could be odd values, because with even value, you are not coming to the result. Like here, if I'm taking an even value, so 2 pink, 2 green, so no result is there. So we need to take the odd values here. Okay. Okay. So now what we'll be doing, let's say this one. So basically KNN is going to use it, like here it is a nearest neighbor classifier. We can call it a nearest neighbor classifier also. This all documents, you can find it out in notes and resources repository. You scroll it down at the end section. In the end section of notes and resources repository, in the end section, you will be finding it out. Links are there. So there you can find it out. Certain links are there. Okay. So basically, this is the same one which I described here. Okay. So actually what happens, how the distance is calculated. Basically now, here, if 2 points are there, so the distance is calculated. This D distance is calculated. Got the point here? This D distance is calculated, basically. And whichever is the minimum distance, that is taken into the consideration. So distance is calculated with basically Euclidean distance. There are certain mathematical distances are there, such as Euclidean distance here, having Manhattan distance, Minkowski distance. So here it takes the Euclidean distance here. So here, this the distance is calculated and finding out the closest neighbor and then voting for the label or the target, that which one is the correct one. This was the Euclidean distance here. This one is the Euclidean distance. Distance D is calculated by finding it out, the difference between node 1 minus node 2, making the square of it and making the sum of with the another node, whichever node we want to work with, finding out the differences, making the square and finding out the square root of it. So this one is a basic formula working for the this one Euclidean distance here. So basically within the 2 points, we are trying to find out the Euclidean distance. So distance D is being found out within the 2 points here. Okay, so let me take a case study here, very important case study that is related with the banking services. Okay, because you should know. See, nowadays, financial services, banking sectors also uses machine learning nowadays, data science and machine learning. So you think it out, suppose one person is going and asking the loan. So nowadays, whether to deliver the loan to the person or not. So again, data science and machine learning are being utilized. Earlier, when this technique was not there, so just by a certain personal or verbal communications, the manager is approving the loan to any person who is asking for the loan. So the point is here. The point is here. Okay. So the point is here that suppose here I am having some data. First of all, you think a situation where there's a person, he needs some loan. Okay. The person is at the age of 48. Listen carefully. I'm giving you a case study. The person is at the age of 48, and the person needs a $1,42,000 as a loan. Now the bank has to decide whether to give a loan to the person or not, because now there is no personal or no verbal communications are there. Means earlier when no data science or machine learning is there, so bank just gave the loan just by asking to the nearby people, okay, there. But because due to there are a lot of frauds, there are a lot of NPAs also into the banking sectors. So everybody is highly cautious that whether to deliver the loan to the person or not, whether the person is reliable, how to measure the reliability. So that is a problem now. So no banks wants to come into the NPAs, or just as people do frauds, they even run away from the countries as well. That is happening in different cases you can read across the world. There are so many, so much happened basically. Okay, so that is there. This PPT I had just started only. This PPT I just started. Okay, Parul, I'm just explaining you. I'm not PPT. I'm just starting. I'm giving you the case study, and I just begin the case study. Don't worry. Okay. So here there is a case study I'm talking about. That there's a person. The person went to the bank. The person needs the loan. The person is at the age of 48, and the person is demanding $1,42,000 as a loan. Now, bank has to consider whether to give the loan or not. Now, it is not expected that every person who is going for the loan is he or she is not returning back. It is not there. But bank has to be highly cautious by delivering the loan. So what bank did, there is a lot of data, earlier data. Okay, the people who took the loan, who borrowed the loan. So there is a lot of data with the bank. So bank started applying the machine learning. With the help of the machine learning responses, bank will decide whether to give the loan or not. So here, let's take, suppose, this is the data here. I'm saying 48 age and amount. The person is asking for $1,42,000. Now, bank started doing the machine learning. Now here there are other previous data for the people who borrowed the loan. So now from those people, there are some of the people are defaulters also, and some of the people are good. You can say it as a good. They gave the loan back, and some are bad people. I can say they did not return the loan back. Can you tell me a few names across the world for the people who did not return the loan back? And there are very famous personality across the world. In a number of countries there are. Can you tell me the names? Because you also know there are a lot of people who did not return. Yeah, exactly. I got it. So there are still, yeah. Malya, everybody knows. Malya is famous across the world. Yeah. So the point is, yeah. Malya is there, all people are there. Okay. So many cases are there. So the point is here, when these things happen now, when the people just borrowed and move away, yeah, everybody knows. So later on, these techniques are coming because earlier what is happening just with the personal and verbal links with the managers. So people are giving, the managers approve the loan, but now not is this possible because it is very setback for the bank. When NPA grows, so it is a setback for the bank even why they are not cautious. Now here, let's take, suppose this is the earlier data. You consider this age. Can you see here age and the loan is provided here. So this is a loan amount. See, focus here. This is the age and this is a loan amount. Okay. Now here, let's understand how this data is working here. So here, someone, let's say any person who is at the age of 25, he or she borrowed loan of $40,000 and they are not a defaulter. N stands for not a defaulter, means this is a list created for the defaulter. N means they are not defaulter. Yes means they are the defaulters. They had not returned the amount back. Okay, so the person who is at the age of 25, he or she has borrowed loan of $40,000. They are not defaulters. It means they are good people. They are good people. They return the loan back to the bank. Now let's see the second data here. The person who is at the age of 35, he or she has borrowed $60,000 as a loan. They are acting as the good actor because they had returned the loan back. So they are the non-defaulters. They are okay. The person who is at the age of 45, he or she borrowed $80,000 loan and the person did return the loan back. So this one is also good person. There's non-defaulter is good. Let me take this case, this one. The person is at the age of 23. He or she has borrowed the loan of $95,000. Oh, so the person is, you can tell me this is a good or bad? This one is a good or bad? Can you tell me? This person is a good or bad by looking at why? Can you tell me? Exactly. Right. So you are saying this person is a bad because the person does not return the loan back. Okay, they didn't return it. Okay. Now let's see the another case here. The person who is at the age of 60, he or she has borrowed $1 lakh. So you can just understand, see, $1 lakh and the age is 60. You can think it now. The person is coming to the retirement age and he or she is asking for $1 lakh. This is too high now. So the person is bad because you cannot say it means bad, but the person does not have this much amount to return back because age factor is also mattering here. So the person is bad. The same is happening here. You can see the person is at the age of 33. He borrowed $150,000. Again, this person is a bad. We can call it because the person didn't return the loan back to the bank. That's why a lot of NPA happened into the banking sector. But nowadays, every bank is highly cautious, okay? Because That is not a good signal for the bank. Okay. So here, okay. So now let's see. So it means what has happened that some of the people are good. We can say they had took the loan, but they had returned the loan back. And these are the bad actors who had not returned the loan back. Okay. Now the bank has to think for this person. The person who is asking for, loan. His age is 48. The person age is 48 and he needs 1,42,000. Okay. Now here comes the machine learning and data science. Okay. So first of all, now here, just wait. Here we start working on to the Euclidean distance, because what machine learning will do, suppose we are applying the KNN. So here the number of neighbors which is being detected. So here it will start working with the machine learning. So before it, what I'll do, let me come to this graph. Now see here. Check carefully. All the dots which are coming into the blue sector, blue. So they are the non-defaulters and red is a defaulter case. Here you can see, suppose I want to apply a KNN. And here I need to give number of neighbors. Number of neighbors, you can see here, I can just give K also. K means number of neighbors. Suppose here initially I'm going to detect, just start checking it out the first neighbor, first nearby neighbor. So student, you can see, wait, this all data points are coming from the below data set. The data set which is here, here. These data points are created from those data sets here. This one. Okay. Now how? Let me tell you. See carefully, students. There is a person into the data set who is approximately nearby 20 or 23 age, and he or she has borrowed approximately $40,000. So he's here and he's into the blue. So it means he's a good person. He returned the loan back. Okay. Okay. Second, suppose here, see this point. This one is some person at the age of 23, 24. He has borrowed $1 lakh. He has not returned the loan back. This one is a bad person. He did not return the loan back. If I say somewhere, I say about 1 lakh, some amount has been borrowed by a person who is at the age of certain 35 or 34. He is also good because he returned the loan back. But you can see here, some person is at the age of 40 and maybe he has took $60,000, but he or she has not returned the loan back. So he is a defaulter. So red is a defaulter, blue is a non-defaulter case here. Okay. Okay. Rohit Paul, just you need to wait, please. You need to wait. Don't be in a hurry. Okay. Now see here, this case now. Can you see this green? See this green? This green is a case where the person is at the age of 48 and he is demanding $1,42,000. This much amount the person is requiring. 48, this much amount, so green signal. So here I'm applying the KNN. So here I'm taking a value of K is equal to 1. So I need to check it out that nearby to this green, which one is the nearest one? Which one is the nearest data points? What happened to that person? So can you see here, nearest data point is this one. See this one, see this one, this. So this person is blue. So it means he is a non-defaulter. So when K is equal to 1, so in this case, the person is a non-defaulter. Non-defaulter means here the person returned the loan back. So here it says that nearby the person is, nearby the neighbor is good. He's a non-defaulter. So we can think some loan, we can think the loan amount that this, we can deliver some loan amount to this person. We can give it because the nearby neighbor is good. He returned back. So this person also can return back. Okay, but not, we should not come to the conclusion. Let me increase K is equal to 2. So K is equal to 2. So when I increase K is equal to 2, I have to check 2 nearby neighbor. So the second neighbor is also blue. 1 and 2. 1, 2. So here both are non-defaulter. So 2 blue cases. So it means non-defaulter. So here, if I'm taking up to 2 neighbors, I can conclude, okay, 2 nearby neighbors are good. They had returned the loan back. So I can think we can approve the loan to this person who is at the age of 48 demanding $1,42,000. But still now I need to make more conclusions. For this, what I did, I am increasing the value of K. So suppose I'm increasing K is equal to 3. So K is equal to 3. I have to detect third neighbor also. Nearby third neighbor is, let's see this one. Oh, so here, 2 blue, 1 red color. But here, the majority is going towards the blue, so non-defaulter. So it is okay. Means all the nearby neighbor is majority non-defaulter. So we can think to give the loan to this person also, the new person. But still, I need to increase this K. So here I'm increasing this K to 4. So K is equal to 4 now. With 4 here, we can see 4 neighbors, 1, 2, 3, 4. So 4 is also defaulter, 4 defaulter. So 2 blue, 2 red. So 2, 2. So it is a 50-50%. 50% defaulter, 50% non-defaulter. So it is a confusion for a bank whether to give the loan to the newer person or not. So here we need to increase K is equal to 5. So I'd increased 5. So fifth one also. So 1, this is 5. So in this case, when I increase up to 5 neighbors I had checked. So here I concluded 3 red, 2 blue. So when this came here, so majority is going towards the red. Red is defaulter. Okay. So students, can you tell me when I came to K is equal to 5 in this KNN algorithm. So what should I conclude with it? Whether the bank should give the loan to this new person or not. See the results here. See the majority going on. The bank should approve the loan to this person or not by looking out different cases here. Everybody should come into the live chat here portal. You can tell me your thinking, your conclusion also, that you can tell me. Okay. Okay, fine. I got your responses. Thank you. Okay. Okay, those who are saying, okay, let me tell you one thing. Those who are saying yes, few students said yes also. Yes means give. So can you tell me why to give the loan? You know why we are doing the machine learning? Machine learning is showing the cases that what had happened earlier with the data sets, earlier with a lot of people. Here with K is equal to 5, it is saying that 3 cases are in red. So 3 cases are red. 3 neighbors are coming in red zone. They all are defaulters. Defaulters means they took the loan and they ran away. That is happening now. And the bank is going with the NPA lot of, okay. So the point is here that 3 people out of 5 went away. Okay, bank is waiting for those people, but they are not coming. So 3 red, 2 blue. So here it is saying 3 cases are defaulter cases. How one is saying that 50% chance is there that the person will return the loan back. Because see, I'll say, bank will never take a chance, you know, I'll tell you. Like if I talk about 20 years back or 10 years back, maybe bank are using all the verbal techniques or personal techniques, but now there is nothing as such with any personal or any verbal techniques. Okay, nothing. Everybody has to perform, every bank has to perform, or every financial domains has to perform, I'll say. Okay, so the point is there is no chance, nobody will take a chance that, okay, let's give, and maybe that person will run, then what you will do? So no, actually one has to come up with a technicality. So here comes the machine learning. Machine, as per the machine, it is saying that what happened to the previous one. With the trained data, it is giving the results that 3 are defaulters, 2 are blue. So here it is saying not to take a chance. Bank will never take a chance. Okay, so the point is, and it is not an amount or small amount, $10,000, $20,000. It is a $1,42,000. It's too big amount. It's in dollars. It's too big amount. So why should bank take a risk? Anybody will not take a risk. So here the conclusion will say, bank will say no, the loan will not be approved because we are not at any risk. Got the point here? So in this case, the bank will conclude that no risk will be taken here. Okay, so that is there. Now the point is there. How this distance is calculated? Okay, how this distance is calculated? This d distance is calculated. This d distance is calculated. This is calculated. This is calculated with the help of Euclidean distance here. Distance is calculated here. Got the point here? So no chance nobody will take it here. So here now, here, come here now. Let's check it out. See here. How the distance is calculated now, and what is the impact of the distance. Suppose 48 is the age of the person and 1,42,000 is the loan amount the person is asking here. So here, D we have to calculate, distance we have to calculate. How to calculate the distance here? So for this, to calculate the distance, I have to take this age. This is the age now, 48. So I have to check it out, 48 minus this percentage, I have to check it out. Just to find out the Euclidean distance here, making the square of it, plus this amount, loan amount, 1,42,000, minus this person amount, how much the person has, this previous person has borrowed the amount, making the square of it. So distance will be calculated. D will be calculated at making the square root. Once this equation is solved, So the distance will be coming as 8,000. So this is the, once it is solved, 8,000 is the Euclidean distance. So this is the distance calculated. 8,000 is the distance calculated here. Okay. Okay, let me tell you, wait. This document, you will be finding it out in Notes and Resources repository. Inside the Notes and Resources repository in LMS. You scroll it down, you'll be finding out the link for this document. It is there. Okay. Now here, 8,000 is the Euclidean distance here. Now I have to check another distance with this data, this one. So how it is going to calculate? This one and this one has to take. Making the square of it, plus how much amount this person is asking? 142 minus this one. Okay, so what is the distance you're getting? You're getting the distance. This one will be the distance here. Next, again, the distance will be calculated for these two with these age and this loan, the previous data. So here, minus 1 lakh. Making the square of it. So what is the distance here? Once it is calculated, 42,000. 42,000. This distance will be the answer. Next. So in a similar way, all the distance are calculated. Suppose here, the distance is calculated with this one. These two. So here 48 minus 52, making the square of it, plus 142,000 here minus 18, making the square of it. So here you're getting this one. This one is the distance calculated. Once the distance is calculated, Euclidean distance is calculated in this way. Okay, so these are the distances. So the point is here, in the similar way, all the distance are calculated for all these ages and all this lawn one by one with the same formula here. So these are the provided distance. These are the calculated distance here. Okay. Now here, we have to check it out. What one is the nearby distance? So we have to check it out these Euclidean distance here. So suppose here I'm saying when I'm using the K and N, K is equal to 1. So I have to check it out. What is the nearest distance? So inside it, I have to check it out. What is the nearest distance? Smaller distance. So this one is 8,000. So with 8,000 Ks here, 8,000 Ks here, it is saying that the means here, the person who is the neighbor which is nearby, he is having the 8,000 as the Euclidean distance, is a defaulter. Okay, the neighbor is a defaulter. He is a bad guy because he did not return the loan. Now, if I increase K is equal to 2, so let me check it out, the second neighbor. What is the nearest second neighbor? Nearest, smaller values here. So 22,000 is the smaller value. So what is the case here? This person is a non-defaulter. So here in this case, one defaulter and one non-defaulter. So it is a 50-50% case. No, we cannot go with the chance. So here I need to conclude it. So I increase this K is equal to 3. So third neighbor I have to check. So if I'm checking it out, the third neighbor, so here 42,000 is the third neighbor. So what happened to the 42,000? So 42,000 is the third neighbor. So here it says, what happened to the third neighbor? He is also a defaulter. So what does it mean? When k is equal to 3, 2 defaulter, 1 non-defaulter. Now you tell me, what should bank decide here? In this case, now it comes to the Euclidean distance now after calculating it. So bank has to give the answer to the person. So what answer bank will give now? Can you tell me? What answer will bank will give to the person who has applied for the loan? Exactly, correct. So the bank will reply here, not approved. Simple. He will not say that you are a defaulter. Okay. Bank will say it is not approved. Got it? Directly, nobody can say that you are a defaulter in this way. He will say that the loan is not approved. The bank do not want to take the chance. No chance, no possibilities of chances here. Very good. That how we can know that how to take with a yes, how many number of Ks are going to be taken. So I'll suggest you basically, whenever we are using a KNN, so here the values of general is 5. I'll tell you 5. 5 is the general values. So by default, 5 nearest neighbors, it is going to check it out. And from here, it will be giving you the final result with 5 number of neighbors. But this one is a minimum number. And it is always odd because one, but the person will never get an even side here. Okay, 50% chance, not odd numbers are there. Now it is up to you. You can give it to 7, you can give it to 9, you can give it to 11, 15, any of that, you can do that. But by default, 5 numbers are given there. Got the point here? Default 5 is there, so I can directly use the KNN. Done. So 5 nearby neighbor, it is going to check it out by default. Okay. You should not go with the k is equal to 4. I am saying do not go with the k is equal to 4. Never give k is equal to 4. Why? I am saying no. Do not give the even numbers. Go ahead with the odd numbers always. That's why by default 5 is given. By default 5 is given here. It will be approving a loan in the condition when maximum are non-defaulters. When maximum of the nearby neighbors are, if suppose I say out of 5 neighbors, when it is checked, 3 they had find it out with non-defaulter cases. So it means if 3 people are with non-defaulter out of 5, so it means all the nearby neighbor cases are good. So in that case, the loan will be approved here. Okay, so this is there. Okay, so let's go ahead with the K neighbors classifier here. You can see here, class sklearn.neighbors, K neighbors classifier. Okay, and number of neighbors is 5. Okay. So by default, 5 is there. Number of neighbors to use by default, k neighbors query. So here, so 5 is the default here. So this I'm going to use it. Okay. So what I do here now, I can take the earlier data set which I had loaded. So I will be adding this code there itself here. Just wait here. I need to check it out. Just wait, students. Here now, I need to find out my yesterday file actually, because I will be continuing from the same file as on I will be writing. Okay, where I had written a name as classifier. So just wait here. I'm just making a stop share. Let me find out the file. Let me find out the file, please. Wait. No, cancel logistic not here. Wait. This one. So I'm going to use this one, new file here. So this file already we had worked, and if you remember, last time I had worked it. So here classification file, I'm going to use it, nearby is classifier. So here itself, I'm going to add k neighbors classifier. Okay. This one I had used yesterday. So yesterday I had created it here. Okay. So let me execute it first. Cell run on. So actually, with the same data set, I can just extend the algo. I just executed it so that I can take this load iris data set here. So here I'm going to add the code for that KNN. Okay, so that I'm going to add it. So I had clicked on run all so that my file could be updated. The same file could be updated. So here I'm going to add the code here. K-neighbors classifier. So here I'm going to call from sklearn.neighbors. You can see the spelling of neighbors. It is different from actual neighbors. K-neighbors classified. Directly I'm running it. So let it be executed. From here, I'm going to take this K-neighbors classifier and see this one I'm taking, this one I'm taking. I'm going to use the same data set. Load iris data set is there. Everything will remain same. Nothing will be changed here. But I'm adding one more code because yesterday for this data set, I had executed which one? Multinomial NB. No, multinomial MNB neb as classifier executed. So now here at the end, I will be adding K-neighbors classifier here. So KNN. KNN is the instance of K-neighbors classifier. Click on run. Here I need to use KNN.fit xtrain ytrain. So training, I'm doing it here. Then predict KNN. This one is there. And now I have to take print. Here I can give what is, and here I can give no. Here I can give predictions. One. Oh, wow. So here with the KNN classifier, I'm getting the accuracy 1, means 100% correct. Print confusion matrix. This is there. So you can see the confusion matrix. Here, all things are green here. All things are green here. Okay. And second, these are zeros. So everything is clean now. So that's why you're getting one as a, you're getting one as a accuracy, huh? Because nothing error is there. Everything is clear. Here it means it is saying that 19 cases, wait, let me create it here, it's better. No, just wait here. No, this is actual and here it is predicted. Wait, it is just reverse. Oh, here it is in this one. Okay, so it means 19 cases for setosa, 13 cases for versicolor, 13 cases for virginica. Other errors are not there, so that's why you're getting 1.0. You should give here predicted and then you should give actual. If you are reversing here, you will be getting the error. That is not the correct way. Here, classification report. So everything is okay. It means you can see here that 45 cases here. Can you see here 45 cases with 45 rows. We have sent it for prediction, where for setosa, we are able to find it out 19 cases, for versicolor, 13 cases are there, and for virginica, 13 cases are there. And the total is 1. 1 means 100% correct, so accuracy score is 1, so your model is working perfectly. So students, can you tell me one thing here? See, K-neighbors classifier is giving you accuracy 1, 100% correct, and even your F1 score. This one is F1 score here, which shows you the model performance. So this is also, it is giving you average as a 1. So, and here, if you see MNB, multinomial NB, that one is giving 95. So which one is good? Can you tell me which one is working perfectly with this iris data set? Multinomial NB or K-neighbors classifier? KNN or MNB? Which one is working good? Which one is working better? It is KNN or MNB, because I'm showing you that what is the F1 score or accuracy coming in both of the cases. Okay, thanks for the answer. So you're saying KNN. So basically, we can take this one data set and can apply multiple algorithm just to check it out, which one is working the good. KNN is working good. Exactly. Good. Now here I can write, suppose here I'm taking this, just wait. Like here right now, my model name is KNN, na? KNN. So what I do here, just wait here. check it out one thing here. Please let me check it out. Wait. I need to check it out one thing here. Oh, okay. Wait, students, just a confusion I'm having. Oh, actual value and the predicted value. A little confusion I was having. Just wait, student. I'm just changing one thing here. Wait. Here, na, like here, I did here. Actual value and the predicted value. Actual value I need to check and then predicted. A little bit confusion I'm here. So I'm just making it correct. Wait. This one, na. This one, na. So here, I'm taking a y-test value here. Actual value. Just wait. I need to give actual value here and the predicted value here. A little confusion I'm having. This one. Let me check with code. Yeah. Actual value and predicted value. Actual value, predicted value. Just it's a reverse. I need to check it out here. I should give it here. Actual value and predicted value. This is a way actually writing. Actual value and then predicted value. And here also actual value in the actual value and the predicted value. A little confusion was there. Actual value and predicted value. Predict M and B. So this is there. Okay. So here just I change it. It was a little bit confusion with me. So here we have to give the actual value. Let me tell you, wait. So in here, whenever we are giving her the accuracy or confusion matrix here, so here we have to give actual value and here we have to give predicted value. So you can take any variable name, whatever name I had given, suppose I had given, so same variable name you can give it. So actual value, which is a y-test and the predicted value. Here also actual value and the predicted value. In this way. So the name of the variable where you had given a predicted value, you can take that. Like here, I did it, just wait here. In this file, I did it. Because I'm using here, I did it now. Wait here. I'd given here. Actual value, predicted value, actual value, predicted value, actual value, predicted value into all this matrix here. Okay. Now here it is okay. So I just made it proper. Okay. So I'd executed it. Okay. The same here, I need to make it here also. Here, okay. Just wait. Predict KNN, I have to take it back. So first y-test will come here. Y-test will come here. Y-test. So actual value and predicted value. Actual value and predicted value. Actual value and predicted value. So the variable name, you can take it here. Now it is okay. I'm rerunning everything now, run all. So remember actual value and predicted value. Here while checking out, a little bit confusion was there. This is correct now. So here, like here you're getting actual value, predicted value, actual value and predicted value. These are the results. And here I'm getting actual value and predicted values. Okay, so that is there. Fine. So in this way, you can do that. Okay, your matrix and your algo use, you can do that. Right now here I can take predictions, means here I can make any values here. Suppose I had defined this particular function. I had created it here. So similar types of function I can create it here. So predict KNN, I can write it here. KNN. And here I need to give the instance name KNN here. And now I can call this predict KNN function by providing a newer value. So I can take any of the values here. Here I can just give the value, but here Because see, I had changed the function name here. I changed the name like KNN. So KNN will be called here. So I can give any value, but here the name of the function will be changed here as I had given the new function name here. So you need to change it, but you have to write it on your own. That is a much more practice you can gather it here. So here I'm taking, here it is Virginica, means here it is saying that if I'm passing these values, then what KNN is predicting here. So these values are moving into the T, they are being reshaped, they are predicted by the KNN. Here it is saying it is a Virginica class because it is returning two as the name of the flower species here. Okay, so here it is saying Virginica, it is Virginica, right? So in this way, we can use that for the prediction with the newer value. Okay, up to here it is okay. Have you understood the basics? Have you understood the basics now? Okay, so you can apply this algo. Fine. Now there is one more algo, such as I say decision tree. Just wait. Oh, wait. Wait here. Let me come. Okay. Fine, got it. Wait. Now there is one more algorithm, such as decision tree classifier. Decision tree classifier. As the name suggests, with decision tree, what has happened? There is a root node, and then there are branch node, and then there are leaf nodes. So we are having the root node, we are having the branch node, and then we are having the leaf node. Okay, root node, branch node, and leaf node here. Right? So basically, decision trees are used whenever we need to take certain decisions. And these root nodes or branch nodes are created on the basis of information gain. The information we are gaining from the columns. If I'm having a column number 1, column number 2, column number 3, so the information gain which we are getting from any of the column, like here these columns are having the data inside that, and these column provide us the information gain, and the column which gives the highest information gain that comes into the root node, and the column which gives the second highest information gain that start coming into the branch node. Now how we can go ahead with the information gain, I'll tell you later. Okay, how this works, I'll tell you in detail later on. But here you should know that there is one of the algo with us, that one is a decision tree basically. So if I check here with decision tree, you can see this decision tree. This is a decision tree. This is a decision tree, you can see. This is a decision tree here, you can see. So here root node, branch node, branch nodes are there. Okay, this is there. So here, if I want to call a decision tree, how can I call it? So simply what you can do, you can write here S wait here, sklearn decision tree. Done. Okay, and here you can click on sklearn decision tree. Sklearn decision tree. So this one is the sklearn decision tree. Here we are having some values for the criteria. I'll tell you what is this criterion. Control C, I can take it. So here I can just take it. So before it now, I have to add it here. Here I can add it as a decision. Wait here, wait. Here I can add it as a decision tree. So from sklearn.tree import decision tree classifier. Okay, you need to run it. So on a one data set, I am using 3 algo. Now here I'm going to use this one. Wait here. Decision tree DTC is equal to okay, and now here I can use predict DTC is equal to DTC dot predict. So any variable name you can make it there. X test. This one is there. Then predict. Wait. Predict, so you took it here, no? Then here it is score here. So actual value, which is a Y test, predicted value. You can give as a parameter here, DTC. The accuracy score is there. You can print confusion matrix. Here, actual value, predicted value. Okay, so here it is working correctly, means 1.0 means 100% correct your working is there. With DTC, this is a tree classifier. And here, you're getting the classification replicate this with one. Got the point here? So here 100% and here also 100% your average is coming. So model, your F1 score is coming also. F1 score, your model performance is giving 100% correct. It means 45 rows we are sending it out, 19 Setosa, 13 versicular and 13 Virginica we are finding it out. So it means I say like DTC in this case and DTC and KNN. KNN. KNN is also giving you the accuracy score 1 as well as its average F1 score is also coming. Model performance is also coming with 1. So it is working well with KNN and your DTC is also working 1 correctly. Your accuracy is also 1 here. And your average F1 performance is also coming. Model performance is also coming 1 here. So it means your model is working well, and you can see the diagonal which is coming here. All the things are 0 here, so it means correctly predicting everything. All the new values are correctly predicting here. Okay, so in this way, our decision tree is working here. Okay, so these are not same values. These are the accuracy scores we are getting. All these are basically accuracy score, precision, recall, F1 score we are getting. It means it is showing that how well our model is working on the same data set. So on IRIS data set currently, KNN and decision tree both are working onto the one as an accuracy score, or 100% correctly it is identifying. Got the point here? So that is there. Now here, there's another algorithm, SVM, support vector machine here. So what I can do, you can see how the support vector machine works. Basically, in case of support vector machine, we are having, suppose I'm having some data, any data, let's say, some data points I'm having. So there's a marginal line between the, in case of support vector machine, there's a marginal line between the two data points. Okay, between the two segments of data points here. So here you can see, suppose if I'm plotting this line, you consider, suppose I'm plotting this line, you consider this line A, this line B, this is a B line, wait, and this is a C line. So can you tell me which one is the better line here? You think that which one is having the highest margin, A line, B line, or C line? So here, the best marginal lines are given by C. Why? See here. Actually, if you see, whenever we are working with the support vector machine, so a large gap is there between the data point and to the central line here. A large gap is there between the data points and the central lines here. So these are the higher margin. We call it a margins. So in support vector machine, the higher marginal line is being drawn, such as C is the line, C is the best line, which is making the highest margin here. Got the point? And if we are having the highest margin between the data point segments, so they are much better because the classification could be easily identified. Okay, so in basically, C is the best line here. So what happens actually when we work with this support vector classifier? So here you can see support vector classifier. See here carefully. Support vector classifier, support vector machine is an exciting algorithm and concepts are relatively simpler. The classifier separates data points using a hyperplane with the largest amount of margin. Means here support vector classifier will be making the largest amount of margin. Okay, it will be selecting that margin where the highest number of gaps are there between the line and the data points. Support vector machine finds an optimal hyperplane which helps in classifying the new data points here. So here wait, see this one basically. Here we are having this line. Can you see it here? This green line. This is a hyperplane. This is a hyperplane, and see, these are the margins. These are the margins. These are margins. This green line is a hyperplane. And you can see the points which are nearby to the hyperplane. So this is a hyperplane. This line is a hyperplane. So this point is nearby to the hyperplane and this point is nearby to the hyperplane. But there's a large gap also. So these points are known as the support vectors, which are nearby to the hyperplane. So basically what happens into this support vector machine, the maximum the margin we are having, it is easier to identify any type of classification group. Suppose any unit which is coming here, a new data which is coming here, which is lying here. So it is easily identified that this data belongs to this group. Or if I'm having any data which is here, so it is easily identified that this data belongs to this blue group. So the point is there in case of this particular support vector machine here. So hyperplane is created and there is a larger margin along with the data points are created with the hyperplane. So here you can see what are the support vectors in support vector machine. So you can see here support vector. These are the support vector. This and this is the support vector, the points which are nearby to the hyperplane. So the support vectors are the data points which are closest to the hyperplane. These points will define the separating line better by calculating the margins here. Okay, these points are more relevant to the construction of the classifier. And this green line, which is making the highest margins, this margin it is making, they are the hyperplane. The hyperplane is a decision plane which separates between a set of objects having different class memberships here. And this one is the margin. If you see, these are the margin. This one is the margin, or this one is the margin here. So these are the margin. This one is the margin. This one is the margin. So margin is a gap between the two lines to the closest class point. This is calculated as perpendicular distances from the line to support vector to closest data points here. And we should be having better with the largest margin here. Okay, so this one is overall for the support vector classifiers basically. Now what should we do here? We need to identify that what are sklearn support vector classifier. So sklearn support vector machine. So support vector machine, I'm going to call it here. This one is a support vector machine. Support vector machine are a set of supervised learning method here. It is used into high dimensional spaces here. So suppose here I need a support vector classifications. So this one is there, support vector classifier I'm having. This one is a support class, sklearn.svm, SVC is there. Support vector classifier is there here. So here I can add it. So instead of this, let me add it on the top here. Here I can add it, this one. Okay, where I added the decision tree classifier. Here I can just call from sklearn.svm import support vector classifier. So here I'm calling it this one. I had executed. Let me run it. I had executed. So this is executed now. So this is SVC support vector classifier. I'm going to use it at the end. Here I'm going to add it. SVC. So here I'm making a SVC as a smaller letter instance of SVC. The capital SVC is the model name. It's the algo name of support vector classifier. So here I'm making SV. Okay, let me take it SV. So SV is the instance of support vector classifier here. I'm running it here. SV.fit xtrain ytrain. Okay. X train and Y train here. Then here I'm writing SV dot predict. But here now, you know, X test I have to give. But here I have to give predict SV. Prediction, I'm going to do it here. Now let me check it out. Predict SV. You can just check it out. What are the values? These are the values 0, 1, 2. It is giving it here. Even what you can do now, students, if you remember when I did this decision tree here, also you can just check it out. Predict DTC. Predict DTC. You can just see the values here. That's I forget it. So in this way, you can just check it out. The same here, you can give it for predict. When you give it here, prediction, so this predict KNN, you can give it here just to watch out the values if you want to watch out the values. Otherwise, you can just use it in accuracy scope. So you can see the values here. You can come here. I had added it. Okay, now here I want to look at predict SV. Then here you can give that is accuracy score now. So we need to give here actual value and the predict SV. It is 1. Okay, so it is giving also 1. Now here you can give a print. It is a confusion. Okay, you can make it a print, and here you can give accuracy, confusion, and classification. You can give it here. Say in this way. Okay. So here accuracy, confusion, and classification is coming here. Is it okay? And now, so it means students see, wait. When I had checked out all these three, so MNB is giving accuracy or F1 score as a 0.95. DTC is giving 1.0. KNN is also giving me 1.0. And SV, or mean support vector classifier, is also giving 1.0. You can take accuracy as well as F1 score. You can take it. Means all are giving as a 1.0. So these are 100% correctly working. This is 95. So it means all three are working onto the one data set. Iris data set means here you need to take one data set and apply all the algorithm and check which of the algorithm is working the best one here. So here, all three are working well. That's all good. We can select any one of them for future. Later on, I'll be telling how to select and why to select. Okay. But here, all of these three are working very well. Is it okay? Now here, I can take any decision tree. Suppose here, no, here I just written SV, no? So SV, I'm going to take it. And here I'm going to make this one a use defined function here for SV. Students, see, it is the best habit that you should write it. Never copy and paste it. 100% you will make a mistake. Okay, don't do these things. I can do anything, but you never know. Because here you are into the learning stage. More and more, if you write the code, if you won't develop a habit of the copy and paste. Today, Means here now at this stage, I'm making a copy and paste just now only. I never made a copy and paste for anything because I keep on writing. That's why the remembrance of the code is possible. If into the initial stages, you start making a copying and pasting just not to avoid like, why should I write 6-7 lines? So no, never do this mistake. This is a huge mistake because when you are making a copying and pasting, then you should never know what internal values you have to change, and 100% you will be forgetting what to change internally. But if you write the code from the very scratch, so it will develop your habit to write the things correctly. Never develop a habit of copy and paste. Today in front of you, I'm making a copy and paste, but I never did it, okay? Because here a lot of code I have to write, so just I'm making it here. But it's better avoid these activities, okay? So here predict test, because you'll never know now what to change and how to change it. So you'll forget it. You will make an error and you will be sending a code to me or my team and say, I'm getting an error. And remember, if you are making a copying and paste, even my team will not have help there because you are not writing the code on your own. You're not writing the code from the very scratch. So that is a mistake here. So never make a copy and paste. Otherwise, some internal values changes, you'll forget it, and that's not a good code for coder or a data scientist. Write this code from the scratch, build a habit. Here I can give any value, any supporting value I can give it. So because now if you do all the things from the very scratch every time, that will develop you a very good habit not to be dependent on any kind of copying and pasting activities. Here it is versicular. See, I can change it. Wait. This is also it is showing. So here it is saying one because I changed predict just to give a predictions. So here it is saying if these values are there, they are belonging to one is versicular. Here if the values are larger, they are the Virginica. Towards number of class 0, 1, 2. So 2 it is Virginica class. In the similar way, you can make a function for, like here I'd written a DTC. Now DTC is there. So you can make a function, prediction function for DTC on your own. Here you can write DTC function on your own. DTC predict function. The similar way, wait here. The similar way I had written it here, na? This one, na? The same way you can make it here on your own for the DTC. But do not make any copy and paste. Write it from scratch. Think it, write it. Think it, write it. Think it, write it. Do not be dependent on the copy and paste. Otherwise, you'll never be successful. Okay, that is the truth. Okay, so this is there. So here you can take any data set. Okay, do the entire ETA, then apply various algorithms. Okay, all the 4 algorithms, you can try it and check it out. Which one is the best one here? For today, till up to here only. Okay, you can just check it out the file. Just wait here. Let me check it out one more thing. Okay, now let's see. Here now I had applied one data set, and on one data set, lot of algo I had decided. Now I want to save the best model. Which one is the best algo here? Okay, so for the best algo here, actually, if you remember, let me write it here. Here, suppose here you think I am see, we are in Jupyter Notebook currently. We are in Jupyter Notebook. So in Jupyter Notebook here, wait. Currently, I had applied MNB, KNN, decision tree support vector. So every algo is just giving its own accuracy or F1 score it is giving. Now, right now, these are the algorithm. Now, suppose I want to take any of the algorithm, any algorithm I'm talking about. I want to take out any of the algorithm from the world of Jupyter Notebook, and I want to store that one into the binary stream. If I want to store them into the binary object here, suppose I say DTC file.obj. I want to take it out. This DTC file.obj, I want to take this DTC from the world of Jupyter Notebook out, and I want to store it here. Okay, so how can I drag it out? So it means here, the process of taking out this particular model from the world of Jupyter Notebook, and I want to store it into the hard disk, and I'm storing that one into the form of binary file or streaming file or object file. This process is known as the serialization. Now, why I'm doing it? Why I'm needing it in this form here? Because you think it, suppose I want to launch this particular object file, which I had created here, means into production. I want to put it here. Production means here, suppose I want to put that one onto the website. Suppose there is a certain www.abc.com, any particular website is there. Now I want to put this file here. So how we can use that? There's this is entire work of the data scientist. Just to play with the data, that's a part of the data scientist. Now here comes the role of developer. The developer person, those who are creating the website, so they are going to put this object here. How? Suppose here this file is trained on horticulture, means plant-based file. This one is a plant-based file, which is work onto the iris data set. So here I need 4 input features: petal length, petal width, sepal length, sepal width. So basically the developer person will create the entire website and the pages which are required, and there is a submit button. Inside the submit button, this file will be called. Now, how a user can use this? So you think out, like there are users who are working into the department of certain horticulture, means flower departments, they are working, plant-based department, they are working. So these are the end users. They are daily working on different plants or flowers, and they want to detect what is the species. So suppose this is a user, he is having any iris flower, he wants to detect what is the data type, what is the category of this flower. So this person will put certain values inside it. Any value, whatever he or she has measured for any particular plant, iris plant here. So here, the developer will give all the 4 text boxes. So this person will fill the values into all those text boxes and want to detect what is this flower is, what is this flower species is. Then the person will click a submit button. After clicking the submit button, all the values will be moving into the submit button and passing inside the DTC file.obj, where this file has been trained already onto the iris dataset. So this file, because this file is already trained file, okay, so we call it a persistent file basically. Persistent file means this file is already learned by the data. This file is already trained by the data. Which data? Iris dataset. So that will just, this file is already trained, so this file will take the new value and start predicting. By taking the new value, it will apply its predict method and will check it out that what is this flower species is, and it will return it as a result. Suppose it will say it is a Virginica. So this end user will get to know, okay, the values which he or she has entered for any particular flower, that becomes to Virginica species. So in this way, the end user is using your particular website where one can put the details and find out this is a Virginica species, or any other details one can put it here. Click on the submit button. And who is putting all this object file into these websites? The developer person is going to do this work. As a data scientist, you are working with the data, okay, where you had trained the model here. So this particular model, we are taking it out from the world of basically, I say, Jupyter Notebook, and it is stored as an object file, streaming file, or persistent file, which is a trained data, which is a trained file. So never think, if I say this is a kind of student who has learned the entire syllabus and sitting into the examination. So once the exam paper is coming, the student is directly giving the answer. It will never go back to learn anything. So this is a trained file, directly it will be used from here. Okay, so whenever we are taking out this particular, DTC or any of these algo here into the object file or binary file here. So this process is known as the serialization. And when we are taking it back into the world of Jupyter, that is known as the deserialization. Now, how we can perform the serialization and deserialization? For that way, we are having a library Pickle. Pickle is the library which is having a method for serialization and deserialization. So Pickle is the library, I can use it. It is having a dump and the load method. Inside the dump method, I can just give the DTC. I can dump the DTC, which will be holding this DTC into the form of binary format. And I can use the load just to load the data back into the Jupyter. So dump method is used for the serialization, and load method is used for the deserialization. This is one library. In the similar way, I'm having a joblib library also. So joblib also has the dump and the load method. Dump is used for the serialization, and load method is used for the deserialization. So the point is here, I can use the Pickle library, I can use the joblib library, any of them. So here you can see here. Suppose this is the library. I'll take just 2 minutes only, that's over. Suppose here I want to save the best model. So what I'll do here, I'll be taking the same code here. Wait here, I can take a joblib method here, import joblib. I can write it here, because suppose here DTC and all three are making the best here. I can select any of the model here. So saving the best model, only 2-3 minutes I'll take it here. And what I do here I'm going to take it, click here. And here I'm going to write this code, import joblib. And this I'm cutting now. For saving the model as an object file here, I'm using joblib.dump method where DTC is taken and DTC file.object is the name of file. So here, whenever I'm using a dump method, DTC model, which is giving me 1.0, so that I'm going to save it into the file name of DTC file.obj. Got it? Or I can write a DTC file 1.obj, any name you can give it. Object is a streaming file, binary file I'm making it here. So I had load the model from the, I had saved this DTC model into the object file 1.obj here. Okay, just wait here. Please wait. This one, up to here, I took it. And once this, up to this line is created, so this DTC file 1.obj file will be created, and this can be used by the developer for putting it into any website. This file, you can find it out here into the home page. Got it? And if you want to reload it, so you can simply write here, joblib.load this file. This file, you can reload it back. This file, you can reload it back. And here you can see this working here. So here what I did, this DTC file 1.obj, this is created here. This is here. And here joblib.load. It is loading it back in any name you can give it, and you can predict the newer data. So this is there, but you can find it out into the home page. And this file can be used by the developer person to put it into the websites. This is one case. This is with the joblib. There is another pickle method also. Second method is a pickle method here. You can take the pickle method here. Here, pickle method is also used here. So here, what you can do, if you want to save any of the data, so simply you can take, suppose I want to save the DTC with the pickle file here. So what you can do here, here I'm writing name of the pickle file, pickle DTC file.pkl into the file name. Here I'm going to use a dump method, pickle.dump. Take the DTC instance from the above and open a file. I'm using a file input output functions of Python. Open a file which is named as a pickled DTC file.pkl into the write binary mod. WB stands for write binary mod. So because I want to write the data into the binary mod, so this method I will use it. These are all file input output functions. I'm using it here. So this DTC will be stored into the form of pickled DTC file.pkl. This name I had given. And this one, you can find it out in the home page. If you want to check it out, you can just search it. And if you want to reload it back from, you want to load the model from the disk again. So simply write pickle.load, open file name. Which file name? Pickled DTC file.pkl into the read binary mode. And you can load it here, you can predict it. So here, here you can see any of the method. This method is using a pickle method. And here you can see we are using a joblib method. Any method you can use it to save the best model. In this way we work. So we just take one data set, do the entire EDA, apply all the 4 or 5 algorithms and find out the best model and save the best model into the object file. Is it okay? In this way, we do basic machine learning here. That's all for today now. Thank you very much. Thank you. Thank you.